Hi everyone, in this video we will be looking at first principles thinking in detail. So first principles thinking is a problem solving method that involves breaking down complex problems into their most basic or fundamental truths and then reasoning up from there to build a solution or an understanding. It was coined by Aristotle, the Greek philosopher, and popularized by Elon Musk in the modern times. First principles thinking breaks down things like this. So it first identifies assumptions. So essentially, what are we taking for granted? Then it breaks down to first principles. What do we know for sure? And third, it rebuilds from scratch. So using only what is true and necessary. So there are 7 tools to master first principles thinking, starting with Socratic Questioning, named after the famous Greek philosopher Socrates. Then we will look at root cause analysis or RCA. There are 4 tools under root cause analysis that we will be looking at individually. Then we will look at mind mapping. Fourth, we will look at blank slate design. So a blank slate approach to a problem. Fifth, we will break down cost and benefit or impact of a problem and see how that can be restructured in an effective and optimal way. Sixth, we will look at what is constraint elimination. And finally, we will compare the traditional analogy versus the first principles approach, and we will look at a 2x2 matrix. Let's start with our tool number 1, Socratic Questioning. Socratic Questioning is asking a series of thought-provoking questions that can help a person explore different ideas. It can help think logically and critically. This was invented, or rather created, by the famous Greek philosopher Socrates. The point of Socratic Questioning is not about getting right answers, but developing better questions and clarifying thinking. So there are 6 categories of questions in a Socratic questioning method, starting with clarity. Then we ask about the assumptions we might be making. Then we look at the evidence. Fourth, we look at different viewpoints. Then we look at the implications. And sixth, we ask meta-level questions like the morality of something, or the meaning of something, or the purpose. Let's look at an example for better understanding. So first we'll look at the problem, then we'll look at the questions we can ask, and finally we'll look at potential answers. So the question we are asking is lying always wrong? So starting with clarity, we can define what is lying. Of course, lying, as we know, is an act of deliberately making false statements or conveying misleading information, often to manipulate, avoid consequences, or achieve personal gains. We ask, are we assuming that all lies have the same impact? Answer to that is, of course, no, because there are different kinds of lies, like the white lies or nefarious lies. There can be lies of omission or half-truths. So context really matters. Then we can look at the evidence. Has lying actually helped someone? Of course, from our experience, we know that there are some lies which are meant to protect people. As an example, a doctor might lie to a terminally ill patient to provide them some comfort in their final days. Then we can look at different viewpoints, different perspectives. So we can ask, what would a utilitarian say about lying? So a utilitarian might say that lying is permissible as long as it maximizes overall happiness or minimizes harm. We can look at implications. What if no one lied? How would the society look like? Of course, there are benefits and drawbacks to that. The obvious positives would be it increases trust and transparency. It also makes sure that people are held accountable. There are negatives like the emotional harm it could inflict. It could also increase social friction. People could lose their privacy, and so on. Finally, we ask the meta question, why is it important to ask about the morality of lying? From the moral standpoint, we can say that it impacts well-being of people. It impacts the trust and social bonds between cultures. There are, of course, cultural and personal norms. So as you can see, for a straightforward question like lying, we can really analyze this in detail with Socratic questioning method. Core characteristics of Socratic questionings are, it clarifies concepts, then it can challenge our assumptions. We can also look at the consequences of our choices. We can test our logic and look at the evidence before making judgments. And finally, it helps us look at things from different perspectives and viewpoints. So that's our tool number 1, Socratic questioning. Tool number 2 is root cause analysis, or RCA for short. Root cause analysis is a structured method used to identify the underlying causes of problems or incidents. We have 4 tools that can be used, starting with Fishbone Diagram. I have done a detailed video of the Fishbone Diagram. I will leave a link to this video in the description, so feel free to check that out. To quickly sum it up here, this is the structure of a fishbone diagram. So we have the fish head and the spine of the fish here. Then we have the bones of the fish, and these lines, small lines, are the sub bones. So we start by defining our problem at the head of the fish. Then we add our causes at the end of these main bones, and then we fill in the specific causes along the sub bones. This is an example of fishbone diagram. Here the problem is declining student test scores. So we fill in our first cause, which could be staffing related. We fill in our specific causes. Then we move on to the second cause. It could be related to the environment. We then go on to fill the specific causes. We list down our third cause, which is technology in this case, and then we fill in the details. So this is how a fishbone diagram works. The second tool is the 5 whys technique. I have covered this in other videos as well. So a 5 whys technique repeatedly asks why to dig deeper into the causes. And the goal is, at the end of our questioning, we reach the root cause. Once we find our root cause, we can develop an action plan. So let's look at an example. Our server just went down. So we asked our first why. Why did it go down? The answer could be the server overheated. Why did the server overheat? The answer was the cooling systems failed. So we keep asking why. We realize that the maintenance schedule was skipped. Then we realized the task was not in the team's work tracking system. And finally, we discover that maintenance task was not properly documented and scheduled. So we arrived at our root cause during the 5th level of questioning. Based on that, we can develop an action plan. The third RCA tool is fault tree analysis diagram. This is how a fault tree analysis diagram looks like. It's a top-down deductive failure analysis method. It's used to determine the root causes of an undesired event, which is typically referred to as the top event. Then we have these logic gates, this OR and AND, that connect the contributing events, which are these basic events. Here is an example of fault tree analysis in action. So our top event is the data center power loss. There could be 2 causes of it. One could be the utility failure or a generator failure. Either of these could contribute to data center power loss. That's why we have the OR gate here. Under generator failure, again, there are 3 causes, 2 of which are connected by an AND gate. Under AND gate, basically both these have to come true for the generator to fail. So the battery needs to fail, as well as the starter motor needs to fail for the entire generator to fail. However, between the 2 of these and the fuel depletion, just one of them has to come true in order for this event to fail. So I hope you get the hang of how a FTA analysis diagram works. The 4th RCA tool we have is the Pareto Analysis. Pareto Analysis says that 20% of causes result in 80% of the effects. This is one way to represent that. Another way is we could visualize this using stack bar charts like this. So here we could also say that 20% of inputs lead to 80% of the outputs. Here is the Pareto analysis in action in the chart form. What I have done here is I have plotted this data in the table. So the orange bars are these percentages here, and this blue line are these cumulative percentages. The goal of this chart is to see if a handful of categories are contributing to the maximum of this chart. So in this case, we can see that item 1 and item 2 contribute to 80% of our overall chart. Let's look at this in action. Here we have 5 items related to car repairs. You can see that 48% are scratches related complaints, then 24% are misalignment issues, and then rest of them are faulty wiring or paint related issues and any other issues. Once we plot this data, we can see that just scratches and misalignments contribute to 72% of complaints, which means we really need to focus on working on these two aspects, and we can deprioritize these lesser categories. So this is a powerful tool that can help us focus our attention on the right things and free up our resources from less important things. So that's our tool number 2, root cause analysis. The third tool we are going to look at is mind mapping. Mind mapping is a tool that breaks down complex problems into smaller components. It helps us organize information, ideas, or concepts in a hierarchical yet non-linear way. This is how a mind map looks like. So we start with a central idea or a topic, then we branch out from it outwards. Each of these branches radiate outwards to represent related subtopics, details, or tasks. This structure mimics how the brain processes information, making it easier to brainstorm, plan, study, or solve problems. Here is an example of mind map. Here the central idea itself is first principles thinking. So one of our branches could be the core concepts of FPT thinking. So core concepts break down into these two sub branches, where first is we reason from fundamentals and then we break down to basic truths. Another branch could be different steps involved in using this approach, and the third branch could be the applications of it. So that's our tool number 3, mind mapping. Tool number 4 is blank slate design. So blank slate design is an approach where we start with zero assumptions, so a blank slate essentially, and rather than relying on similarities or legacy systems or conventional wisdom, we ask if we could start from scratch, what would we build and why? This specific approach is used in user interface design. So essentially, when there is no data or content that exists, how do we fill that empty state? Looking specifically at UI design strategies, we can break down blank slate design approach in these 8 categories and compare how this approach differs from a traditional approach when filling the empty state. So let's say if a user lands on a website for the first time, what do we show to that user? Do we just show nothing, or we give them something to do? So the approach blank slate design uses is an active approach. We would rather give them something rather than nothing. This approach is very clear in terms of guiding a user. The visual appeal is friendly. In terms of engagement, we want to encourage them to interact with your product. The onboarding experience itself is included in your blank slate approach. So the user doesn't need to look at third-party solutions or manuals or videos to really understand how to work with your website or product. We also give them example context that can help them understand how to work with your website. When it comes to assumptions, in a blank slate design approach, we keep an open mind and question our traditional approach. Just because we did something a certain way, should we assume that it's still applicable in your case? So our approach in this design is always be questioning our assumptions. Finally, when it comes to use case suitability, this approach is useful for onboarding new users. Here is another template of the same visualization. Here is an example of blank slate design in action. So this is a mock website application that helps users manage their tasks. So as soon as a new user lands on your website, instead of just giving them nothing, we can welcome them, we can prompt them to try something, give a button to get them using your website right away. We can also provide tips that can guide them. So you can see all these principles are applied in this mock example. Applying the same approach to a non-UI context, let's say you are arranging a community workshop for your students, you can start by giving them welcome booklet with a sample project. Then you can give them pre-prepared materials kit, so they don't have to go around looking for materials. They have those right there to get started with. Next, you can give them a facilitator-led first activity. So someone is there to guide them to do their first workshop or an activity of a workshop. And finally, you can give them a roadmap or a checklist to help clarify what they are supposed to be doing and help them document their journey. Let's look at one more example. Let's say you are arranging a cooking workshop. In a cooking workshop, you can give them a welcome recipe booklet that is simple, beginner friendly. It gives a step-by-step prompts with visuals. Then you can also give them some motivational tips. Then you can give them starter ingredients kit. So pre-measured ingredients. You can also give them all the necessary tools at the beginning. Next, you can again give them a facilitator-led demo. So show them a short live demo of 10 minutes or so. Have some interactive prompts, offer some tips and early praise to keep them motivated during your entire workshop. The last step is similar to the community workshop, is giving them a visual roadmap and a progress tracker. So as you can see, a blank slate design approach rethinks the traditional way of doing things. The fifth tool we are going to look at is cost-benefit disassembly. Cost-benefit disassembly is a method of breaking down problem, system, or ideas into their fundamental components by weighing each part based on how much it costs in terms of the efforts, the time it takes, or the resources needed, and then compare it with the benefits it can provide. So benefits could be impact it has, utility, or the value it provides. Here is the process of applying cost-benefit disassembly method. First, we start by breaking down system into individual components. Then we assess the cost, whether the cost is in terms of time, money, complexity, or risk. We decide our first axis. Then we assess the benefit, so the other axis. Here too, the variable could differ. It could be value-based, performance-based, or outcome-based. Fourth, we then plot them in the form of a XY scatter chart. So this is how our chart could look like. On the x-axis, we have cost, and y-axis is where we are placing benefits. We then break down our chart into 4 quadrants. Anything that's high impact, low cost, that's a good thing. We can look at how to improve that. Anything that's low impact but high cost, we can look at eliminating that. For the rest of them, we can decide whether to keep them inside, or we can maybe outsource those, or whether to restructure or improve those. Finally, as I just mentioned, once we have this chart figured out, we can start acting on it. Here are the benefits of this method. So it can help us isolate high impact, low cost components. Then we can identify which are the low impact, high cost components. And finally, we can optimize or redesign from the ground up based on all this data. Here is a detailed visualization for cost benefit disassembly in action. Here I have created an assembly line illustration for this method. On the left hand side, this is where our components are. Once they go through this disassembly process, we can then classify them under different action plans. These headers at the top are the action plans. So let's say if we decide that component 1 is good for further optimization, it can fall under this category and so on. Here is an example. Let's say we are redesigning an electric vehicle from first principles. Think of Tesla. We break down our design process into these 6 components. We then give the weightages to each of these categories under cost column and benefit column. And then based on the quadrant that we saw, we start listing down the actions for each of these items. So battery pack is a high cost, high impact item. We decide to optimize it. Infotainment system is a high cost, low benefit item. So there is no point in spending efforts and money on this in-house. So we can just decide to outsource this or try and simplify this and so on. Here is how this data would look like in a chart form. As you'll notice, infotainment is something we can choose to eliminate. Regenerative braking is a high impact, low cost item. So we need to keep it and make it better, and then so on for the remaining 4 items. This is the visualization for the same example. So the battery pack goes under optimize, infotainment system goes under outsource, and so on. So that's our tool number 5, cost benefit disassembly. Tool number 6, constraint elimination, is an approach that involves identifying, questioning, and removing or minimizing constraints that restrict our system or a process or design so that we can achieve a more optimal or innovative solution. This is one option of how we could visualize constraint elimination. So here the smaller square are our initial possibilities. The shaded square is our constraint. Once we apply constraint elimination method and remove the constraint, our initial possibilities expand to take up the space of this larger rectangle. We could also represent the same thing in a circular form. Next, let's look at an example. Let's continue with our battery example from electric vehicles. We are trying to maximize our sales. However, the constraint we are facing is that the batteries are expensive. That's really limiting any cost reduction we can make that would boost our sales. So then we do our constraint elimination analysis. We decide that we can improve on the batteries. So we can look at alternative materials for battery, or we can look at improving the techniques used in manufacturing batteries. And once we eliminate that constraint, our sales can increase. Here is another example. We are trying to improve our sales. However, people are concerned with the range. So in order to increase the range, apply constraint elimination method for a longer range. Here is another visualization for the same method, but much more detailed. So we start with our traditional constraint on the left hand side here. We list down the assumption we are making. Then we apply the constraint elimination method, which is 3-step. First, we ask the question, then we eliminate, and finally, we provide a solution. Once that's done, we list our outcome. So here is an example. So we are specifically looking at reusable rockets. We list down our 2 constraints. The problem is that the rockets are single use. They are discarded after single use, which costs millions of dollars per mission. As Elon Musk mentions, it's like every time you fly on an airplane, you throw away that airplane at the end of your journey. Then we list down our second constraint related to manufacturing. Why does it really take so long for rockets to be produced? Turns out that the rocket manufacturing process is inefficient. The manufacturing is spread across the country in different parts, which adds to a lot of logistical delays. So to make that process efficient, maybe the solution is to move everything in one plant or close to it. We then list down our assumption. Rockets must be expendable due to engineering complexity. Then we apply the constraint elimination approach to this problem. We then question, why are rockets single use? We then eliminate by developing reusable rockets, by redesigning everything, and finally we provide a solution with an actual reusable rocket. So the outcome is that it saved taxpayers hundreds of millions of dollars. Also, it accelerated rocket manufacturing. That's our tool number 6, constraint elimination. Let's look at our tool number 7. Analogy versus first principles matrix is a mental model used to distinguish 2 different approaches to problem solving. So let's look at this matrix in action. So here I have familiar problems and here I have new problems. Let's see how they compare with analogy-based approach and first principles approach. For familiar problems, analogy method is quick to replicate because we have existing experience to pull from. If we are to compare that with first principles approach can help with efficient optimization instead of just a quick copy paste of an older tried and tested approach. When it comes to new problems, we risk making faulty assumptions under analogy model, but when it comes to first principles model, because it's so robust in terms of thinking, we can come up with original and custom solutions which are inherently hedged against risky assumptions. Here is a template for applying this mental model to an actual problem. So our columns remain the same. However, for these rows, we have thought process and outcome versus familiar problem or new problem. Here is an example for electric car innovation. For an analogy-based thinking, we ask questions like, hey, we know how cars run. They run on gas. We have a combustion engine. All we have to do is just replace that engine with a battery and a motor, and voila, we are done. However, the problem with this approach is that you cannot just substitute a combustion engine with an electric motor, because if you just did that, essentially what you end up with is a EV that looks and behaves like a gas car, and it may not be optimized for battery weight, range, or cooling. So what you might end up with is an inefficient car, which is what actually happened with some of the companies in early days. Compare that to first principles approach. We ask questions like, what is a car really? It's a transport pod that moves people. So what is the best way to power and build that pod from ground up? Once you ask these questions, you can really get to the bottom of a problem and redesign a car that's optimized for this type of vehicle. Unsurprisingly, the outcome for analogy-based model would leave us with an expensive and inefficient electric vehicle. But for a first principles-based design, we get something like Tesla that's optimized for battery chemistry as well as the aerodynamics. Here is another visualization for the same comparison. That covers our tool number 7. So I hope you found this video useful. I will be leaving a link to the file with these different visualizations in the description. If you got any value from this video, please leave a like and subscribe for future videos, and I will catch you next time.